Hello and welcome back to compiler programming. In this video, I thought it's time we get back to the structs, add a nice builder to it, and also implement the proper alignment as described in MSDN specification. Because right now, what we have is what is called Pextracts, which means that we don't care like what are the sizes of each of the descriptors that we have, or each of the fields, and we just like stack them one after each other. So let's say that if we change this to be 8, that means that in the memory, the resulting layout will be 1 byte, or how do I specify? Let's say that the first field is X and the second field is Y. So let's just say this is called X and this is called Y, and each character would be 1 byte. That means that the layout would be like this. But if we look at the specification, this is not at all how it's supposed to be. When you have a setup like this, which is sort of exactly the same as they have here, and you're supposed to have padding before the next field. So it should be like, actually there is one Y missing here. It should be like this, right? So there should be X and a bunch of padding, and then there should be Y. And the total size will then be 8 bytes. Another thing about padding, at least as I understand it, is that the whole struct is supposed to align to the largest alignment of the fields. Because if it doesn't, then you will have problems when putting this stuff into arrays. Like imagine that we tried to put, so let's say that we have this layout. I guess it's fine, or maybe not. The point is that we want to always have the same boundary when we put this. And if we start doing this, then iterating over X will constantly be in a different position relative to 4-byte alignment, or whatever alignment or alignment we want to have. And that means that in certain cases you will have performance penalties for CPUs fetching it, and in cases like when you use a SIMD instruction, they will just simply throw a CPU error and not work at all. So your program will crash. So alignment is important, and this is something that we have to implement if you want to nicely interpret which we see, which is necessary. Otherwise, you won't really be able to do any proper system calls or stuff like this. Yeah, so now that we get this small explanation out of the way, the first thing I want to do is actually turn this into a builder like we have for functions, because this is obviously not a very concise way to specify this stuff. But the first builder I actually will add is for the pointer, because this is super simple, and it's also going to be very nice to have this helper available to us. So let's look at what we have here. We actually need value.c, and we have already a bunch of helpers for value from S32. We can, for example, add value star. I don't know if I should say pointer to or address off. I guess it's pointer to, and it accepts. Should it accept a descriptor? Yeah, it should accept a descriptor and return a descriptor. So Actually, we probably want two versions of this. One will be the value, the other one will be the descriptor, but right now let's call it descriptor pointer too. Descriptor is their descriptor, and we just copy this stuff that we have here into the new code. We say return. Actually, we have to do the same dance as with this stuff, where we allocate it and then we assign this stuff, and only then we return it. Okay, const descriptor, that's good. Return result, and here we say pointer to descriptor. We can build this, but we are not using it yet, so now we can add this helper and say descriptor pointer to size struct descriptor. Don't know. Yeah, now it returns pointer, so we don't need to do this. It still works. Let's run all the tests and see how it goes. Okay, everything is fine. That's the first thing out. Now we can continue with the array. Okay, or actually with struct, sorry. We want a builder. Let's copy paste this stuff somewhere above so we can look at it later and see how we want to deal with it. So I guess one thing that we definitely need is a way to track the offsets, which is going to be very similar to how we deal with the stack, and stack also has to deal with alignment, but I don't want to merge these two together just yet because I'm not entirely sure that the rules are the same. So I rather play it safe and have separate code paths for them. And if later we realize that we can unify the logic, then great. Otherwise, it's also okay if it stays like this. Okay. We want to have some kind of structs, which is going to be called Struct Builder. It will have, well, I can do 32, it can be offset. And then I'm not sure if we want to have some kind of like end build thing, or we can update all this stuff as we go. Let's say that we can update all this stuff as we go. And as far as the fields go, we can either turn them into a linked list, which is probably not very good, or keep them as array, but it will be a bit fiddly in terms of allocating bigger arrays if you need to. So I will probably over allocate and say, oh, our structs cannot have more than whatever 128 fields or 64 fields. Doesn't really matter right now what is the limit. We are not gonna use it in reality later anyway. Okay, so we should then have pointer to descriptor, or maybe we should just have the end build thing. Let's have the end build. Then we realistically only need to track the offset of this stuff. So let's start with that. Okay, we need struct builder struct begin. Okay, it doesn't need to accept anything. It's it will literally, we might not even need struct begin because it won't do stuff. So okay, then but we do want to have something like add field. And what we could do is we could keep them as a linked list while we build it out, and then once we know how many are there, we will just change it to what we want. Okay, that sounds actually quite reasonable. Struct Builder field. And what we say here is that this thing contains a descriptor struct field star. Descriptor, or let's call it descriptor. And then the other thing that we need is a pointer to the next field. So next, like so. And then we say struct builder field star fields. Or fields list to be more explicit. Okay. So now we add a field. A field will need to have a descriptor. Let's call it like this. Descriptor star descriptor. And we obviously also want to pass our struct builder here, because that's what we need to keep track of everything after all. And as far as return type, let's start with void for now and then see if we want to actually return something. Maybe we would want to return this stuff, but I'm not entirely certain, so we'll see. Okay, so we want to have a sort of a pointer to the last pointer where we want to insert the fields, because the order of fields actually matters. Although we could do it at the very end, it doesn't really matter. Let's do it like this. Let's just start with easy construction and then make it more complicated later. Okay. We want to make new one of those. Oops. Star builder field is temp allocate of this. So we have a builder field. Let me think about this. I can actually make this just part of this thing instead of a separate. Yeah, that's fine. Okay, so we then say builder field dot or arrow struct field, and then that thing has a descriptor, which we passed to us, so no need to fuss about that. And then builder field offset is our builder offset. And now we want to say builder offset plus equals descriptor size. What's it called? Descriptor byte size. Descriptor byte size of descriptor. And here we say to do alignment, which is the whole topic of today's video. But first, let's implement the current situation, make sure that all the tests pass, and then we can start enhancing it with more functionality. Okay, so this is neat. What can we do next? Now, we have add field, and we say, let's call it struct add field or some namespacing, and then struct end. And struct end should return to us a descriptor for the struct. Maybe I will create struct begin, just even though it won't really do much, just so that we have more symmetry with other stuff that we have. So let's do this. Return construct builder, and then essentially we can just do this. Just zero initialize it. Okay, so we have struct begin, we have struct end. Struct end is supposed to accept a builder and nothing else. And as I mentioned, it needs to return to us this stuff. But we need to do a bit of work before we can actually make it happen. So the first thing, now it's a pointer. It's called result. We want to temp allocate that pointer as well, which is going to be like this. Now, what we do next is we say result type is descriptor type struct, and result struct is as follows. So now we want to figure out how many fields we have, which is very easy. We have a variable to keep track of that, which we didn't use, but we totally can. We say builder field count plus plus. Okay, so that means that we can allocate the array of the right size for us. And that would be descriptor type fields, this thing, right? It's like so, fields, and then we want to say temp allocate, and I think I also have this version. Let me check. Oh, I only have temp allocate, but I don't have temp allocate size, because sometimes I don't just have type, I instead have size here. So it's going to be like this, and we can now say that temp allocate is actually temp allocate size of type, like this. Sounds okay. Now we can say temp allocate size of what's gonna be, it's gonna be size of descriptor struct field times times builder field count. Okay, that's good. We should actually assert that we have fields, because at least in C, it's not allowed to have a struct that does not have any fields. Like, we could consider just adding a 1 byte field, but I rather have defined behavior that is a bit constrained than this weird stuff. Okay, so we have fields. Actually, yeah, this is like this. And now we have to say, actually it's going to be void star, I think. So it's perfectly fine. What does buffer allocate size return? Yeah, it returns the void star. So this is okay. We have fields. So we have, actually call it field list. So it reads nicer, and field count is builder field count. Okay, this is neat. We return result, but we haven't actually put the fields in the right place, right? We just allocated the the place for them, but we have not done any copying. And because of the way we gonna deal with the adding fields, which we also haven't finished yet, our field list will sort of be in reverse order. So the way it works is, now I say so we create this builder field, right? And we say builder field next is builder, what's it called? Field list. And builder field list is now builder field. So sort of this pair here, as I mentioned, it makes it aligned in reverse order, because we are taking the last one and saying that the last one is the next of the current one. Or is it actually reverse order? Or is it the right one? No, it's even, no, it is reverse order. Sorry, getting confused there for a moment. Okay, so that means that now we have to go back to front and say u64 I is 0, I is less than builder field count plus plus I. Or how shall we do it? Actually, we probably should do it slightly differently. Say wild struct builder field is like this, and then we iterate over the field list and our index would be, as I mentioned, the reverse of the array that we are writing this into. Okay, so e64 index while filled. When we say that field's index is star, or actually field struct field. Okay, and then we say field is field next. It's going to be a bunch of errors, but we can fix them, no problem. Apparently we also can crash, but this is fine. Where are we? Struct Builder. Okay, I was right around here. Okay, field is field next. Result struct is const descriptor struct, I guess. Field list. Offset is not a member of Struct Builder field. Yeah, the offset is part of this stuff. That is true. And here I need to say it like this. Okay, making some progress. Here it's supposed to be this way. Okay. And field list is undeclared identifier. Indeed it is. Okay, that's good. Now we can get rid of this stuff. Okay, what do we, maybe when we return this, we return the struct builder, or even better, the struct field. So descriptor struct field, this is what we're gonna return here. And this is gonna be then this way. Okay, this is good. We don't need this. And we are ready to try to use it in our code. So, struct builder, struct builder is struct begin. Now we say that size or descriptor star size struct descriptor is struct end of struct builder. That's good. Let's add a block in between to showcase that this is the body of this. And we have to deal with fields, actually. Unfortunately, we have to not put it in here, which will actually cause some difficulties for us to later figure out how to get this fields or how to use them. I think eventually we might have to add names to them so we can look up them by name, which is not going to be very fast, but it's fine. We can survive that for now. Okay. We want these two things. Width field is going to be the first one, right? So we say struct add field of struct builder, and we need to pass a descriptor, which is going to be descriptor s32. Okay. And now the second one is going to be the same thing. That doesn't look half bad to me. And we can get rid of all the previous stuff. And somewhere here, we probably are using size struct descriptor. Okay, yes, that's good. And we don't need these two anymore. It builds. Let's see if we messed something up. It looks like we didn't. So let's save this stuff and try to make it break, right? Because the problem was for us that if we change this to 8 here and change here to 8 and change our code to 8, now it should do really bad things. So let's check it out. It builds, but if we try to run tests, I think it should explode. Yes, it does definitely explode. So let's figure out what is going on. For that, we will need to launch our Visual Studio Debugger and see what does it say to us about the assembly that we created. Okay, start. Disassembly, ding ding ding, and let's look at the code. So it moves to AreaX and moves to here, so it puts it at I'm a bit confused about this, to be honest. So this RCX plus 1 is what I assume it's the height field. So we move it to RSP. And then we move, oh yeah, it's really wrong right now on multiple points actually. How can we test this without digging into the multiplication stuff? Because the issue right now here is that even though it's actually a byte value, we are loading the full thing there, which is not how you would want it to be handled. So yeah. How shall we do this? I guess the same problem should manifest itself if we have 8-byte and 4-byte stuff. Let's actually check this. So I think if we do this, we might have the same issue, but I'm not entirely certain. At least I'm interested in what is the size of this struct. And it doesn't say to us. If I start, does it say to us what is the size of it? Size of size is 16. Okay, so at least there is definitely padding, but the question is, what is the offset of each of the fields? So I think there is an operator for that, but I can just do it like this. Size height minus size. Expression must have what? Oh yeah. Okay. What now? Parent types are incompatible. What do you mean they're incompatible? Well, I guess let's do it that way. Char star here and char star here. Okay, good. So at least it has the same issue, and if we look into disassembly, we should probably also have the same topic. So yeah, we load this value there, and you can see this +4, which means that our alignment considers that variable to be at offset 4 rather than at offset 8, where it should be according to this calculation. So this is something that we need to fix. Now, how are we gonna fix this? This is an interesting question. One way we could do this is we could say that, so when we are adding a field, we need to align the offset to the size of that field. So let's do that. Say 64 size is this, and this is what we're gonna do. And now we need to, I think I called it align builder offset size plus size. Actually, we first need to do the alignment, and then we can do the addition of size, because we use that alignment here to specify where the field is going to be. Okay, this looks promising. Let's check it out. And hooray, it works. Good. So there is still one more thing to consider, and I believe we will also have a problem. So let me stash this or add it to index. If we add another field that is like, I don't know, whatever. Actually, we don't even need to name it because we're not going to use it in any calculation. But the idea of this field is it's going to be 32-bit field. And if I understand correctly this definition here, because we have an 8-byte field, the whole struct needs to be aligned to 8 bytes. And that means that the size of this struct will be 16 bytes and not 12 bytes. But I might be mistaken about that, so let's check what happens if we do the same thing to C. 32 done, yes. Okay. Let's start. Yes, there is no test, I know. Okay. Now I want to know what is the... size of size is 24. Yes. Actually, I was wrong, not 16, 24, because the first 4-byte field is expanded to 8 bytes, and there is a proper 8-byte field, and then there is a 4-byte field that is again padded to 8 because it's at the end and we want them to align to correct positions. Good, so I understand this correctly. And we can actually add another check into here that will check what I was now doing manually and saying size of size is the same as well, I guess we do struct builder offset. Okay, if we do test now, it should explode. Yes, it's not the same thing, so let's make it the same thing. Okay. For that, I guess we need to keep the maximum size of whatever we have. So let's call it max size. And we say that builder max size is, let's just write it out. There's probably a macro for this, I'm not sure. Maybe we can try max of builder max size and what? And size. Okay, no, I don't want to go there. Okay, so apparently, yes, there is a macro for that. That's good. That doesn't really change anything because we are not using max size. Now we have to say that builder offset is going to be what? Builder offset is align of builder max size or align of builder offset to builder max size. Let's check that. And it's better. Good. I'm really happy with the result. We have a pretty concise way to define structs. Might create a macro later, but as I mentioned, the problem if we do create a macro will be that it's unclear how to like if we put it inside a for loop, then we can't really kind of get the fields on the outer side of the loop because they will be in a wrong scope. I will think it over what I want to do with this, whether we will go with named fields or we will just keep it like this for now, but this is going to be later. for now, we made a really good progress, and the program looks much cleaner. It also is now obeying the rules, at least most of them from the MSDN specification. So that's going to be it for today. Thank you very much for watching, and hopefully see you next time.